Who? No.
Okay. So Lakshmi Narayan Mittal is a steel tycoon. He is an industrialist,
Okay.
and he is pretty rich. So okay, let's check him out. Let's say Bill Gates went and he bought a property in this particular household, this particular area. So this guy here sold a property to Bill Gates, and Bill Gates bought it. He thought, I'll give it to my driver, and he would go and stay in this particular household. He gave him as a gift, right? The property was still registered in the name of Bill Gates. Okay, so now you're gonna help me out here. What is the average or household income of Mr. Gates? Hmm. For ease of calculation,
Sure.
shall I take 100,000? I know I'll not
Sure.
be right, but then there's a limit to the zeros that we can add, right? So,
There you go.
so let's go with 100,000. Yeah.
Sure.
As we always calculate average, so let's calculate average. So now the data went back to the government.
Mm-hmm.
The average income, on an average, how much people living in this particular locality earns? They earn about 15,000, somewhere about 16,000 pounds every month. Okay, if somebody comes and tell you this figure, your immediate impression would be, we have filthy rich people living there, right?
Mm-hmm. Right.
So this is exactly what they thought. Oh, and they thought, what we have been doing, we have been giving subsidies to people living in this area. Let's cancel all the subsidies and let us impose heavy taxes. Right? They wanted to, take money from here and give it to people living in some other household. So what has happened here? One, Mr. Bill Gates changed the entire equation. Right?
Right.
People here, other folks are still, if you calculate the average of rest of them, it is actually lower than 2,000.
Mm-hmm.
Right? But then if you add Mr. Bill Gates to the equation, it is giving a wrong picture altogether. So this is what average does to you. Okay, so
Right.
average, looking at average alone can be bad. Now let's calculate the other measure of central tendency, which is median. Let's calculate median here first. We'll not arrange it in ascending or descending. We'll simply apply the formula. But you know how we can calculate, right?
Right.
If you calculate median for this, again, it will be 2,000. So do you think which data or which measure is more closer to reality out of these two?
Median.
Median, right? See, whenever there is no Bill Gates in the data, still it is equal to mean. If there is Bill Gates in data, still median is giving me the right representation. Because of one Mr. Bill Gates, everybody else is not suffering. Right? So looking at mean alone can be misleading because mean tends to get impacted by the too high or the too low values.
Sure.
Right? So that's the reason why we say looking mean alone is bad. Let me just again take an example. So let me do. So here is a river, right? And you want to cross this river. And you ask me, what is the depth? I say on an average, so it is somewhere about 4.5 feet. Are you taller than 4.5? What? You're taller than 4.5 feet, right?
Yes, correct.
All right, great. So you'd be able to cross it easily. Is that right?
Correct.
So remember the keyword here,
Average.
average. So you ask me what is the depth of this particular river? I say on an average it is 4.5 feet. So they, oh, it's okay. I'm way taller than that. So let me just cross it. I did not tell you that from here till here, it is 12 feet. Okay, and rest from here to here, it is somewhere about, I don't know, 1.5 feet or something.
Mm-hmm.
And rest, we can say 3 feet. Now, if I give you insight, this insight, now tell me, would you cross the river? Assuming you don't know
Right.
how
It's
to
too deep.
swim.
Right.
Too deep, right?
Mm-hmm.
Right. So this average here, it doesn't mean anything to you, right?
Right.
So I remember when I was being trained by my master black belt. So he gave me the example, to explain this. Why one hand is in the oven, and other one is in the chiller. On an average, I am fine, right? So
Right.
that is what average does to you, right? So you
Mm-hmm.
should not look at average alone. Okay, so let's go back to the three measure of central tendency: mean, average, median, and mode. Okay,
Mm-hmm.
there's a limitation to mean or average because it tends to get influenced by the too high or the too low values. Median is the more accurate one, more correct, because what you need to do is you need to arrange the data into ascending or descending order, and then take the middlemost value. Mode is the most frequently occurring data set. So if we look at the same example, mode. So mode for here is 2000, 2000, 2000. So it becomes 2000.
Mm-hmm.
Okay, it doesn't have any mode because there's no repetition of number. Okay. So in Six Sigma studies, we don't do till black belt level. We don't do a lot of analysis on mode, so we will not concentrate too much on mode. We'll only talk about
Okay.
these two measures, which is mean and median.
Okay.
Okay, so remember, what is measure of central tendency? What are these values? It is telling me where is my data centered. What is that one value which tells me about the entire data set? Okay. Now, what is measure of dispersion? Any guess? What do we mean? Your dispersion would mean how spread out my data is, right?
Okay. Yeah.
So there are three measures of dispersion: standard deviation, variation, and range. So let me ask you, do you remember what is standard deviation?
Standard deviation
Yep.
is similar to average, isn't it?
Not exactly.
Okay.
So how do we calculate? So let me just, I'll delete this one.
Okay.
Okay. So let me convert it back to Mr. G. So I'm removing this data purposely. So let's, so in statistics, you know, X bar means average. Okay. So how we calculate? So what is standard deviation doing? You know,
Oh, it's plus or
to get the
minus
average.
of the average. Yes, I
Absolutely.
remember. Yes.
Right. So what it is doing, if you look at the formula here, you know, let's calculate it. Right. So it is saying
Okay.
X, which is this, minus X bar, which is the average.
Mm-hmm.
What it has done, it has calculated the difference between this data point and the average.
Correct.
Then, so let me just freeze the cell. Then what it has done, it has again calculate difference between this data point and the average.
Yep.
Okay. Then this, like that, it has calculated distance of each and every data point from the average. Okay.
Right.
You good with this? Right.
Mm-hmm.
So if you've calculated it right, ideally, the sum of everything should be 0.
Mm-hmm.
Right. So let's
Right.
calculate sum is 0, because it is calculating distance of each and every data point from the average. So there would be certain point which will be above average, some point which will be below average, because remember, average is the middlemost value.
Mm-hmm.
Okay. So, but there are certain negatives here. So in order to negate the effect of negative, we will square this. Which is called, so square of 0 is 0, square of minus 100 is 10,000, plus
Mm-hmm.
10,000, plus plus 100, positive 100 is 10,000, positive 200 is 40,000, and negative 200 again is 40,000. 0 square is 0, 0, like that. Sum is 100,000. Right?
Mm-hmm.
Okay. Now, how we calculate standard deviation? Okay, let me just. So there's a formula for doing it as well, but we're doing it right now so that we are able to understand the concept. So square root of x minus x bar square plus, so what is happening, this would become x1, the first data point here, x2 minus x bar square plus x3 minus x bar square till xn minus x bar square, divide the entire thing by n minus 1. So this is the formula. Under root of x1 minus x bar square, which is this right here, plus x2 minus x bar square plus x3 minus x bar square plus x4 minus x bar square, x5 minus x bar, x6 minus x bar, and x7 minus x bar till xn minus x bar square. If we would have had more numbers here, we would have done it more times. Divided by n minus 1. So n is total number of data points. So we have 7. 7 minus 1 is 6. Divided by 6, under root of this would give us a standard deviation. Okay, so understand this formula. So if we look at this particular formula, what it is doing, it is calculating distance of each and every data point from the mean. So now let's look at it in the presentation. So so if this is the data right here that we have, and let's say this is mean. Okay, so now what, so if you look at the formula, what it is calculating, it is calculating, so we have squared it because we want to negate the effect of minus. But if you look at the formula, what it is trying to do, it is trying to calculate, let's say we have a data point which is right here. It is trying to calculate how much is the difference between this data point and mean. Then let's say this is the second data point that we have. Then it is trying to calculate difference between this data point and the mean. So it is calculating distance between this and this. Then it is trying to calculate difference between this and this. Right? Scott, are you able to follow me?
Yep, so far.
All right, great. So basically, it is trying to calculate the difference between mean and the data points. Okay, so ideally, what do you think the direction of good for standard deviation should be? Should a higher standard deviation be better, or a lower standard deviation be ideally for any process?
Should higher or lower? A lower standard deviation is better, right?
Absolutely. The lower the standard deviation, the better it is for the process. In a nutshell, what it means is that all these data points are very close to each other. Right? So that means you have a predictable output. So if it's the average handling time, let's say the first call that you monitor, average handling time is 20 minutes. The second call you monitor, average handling time is 3 minutes. Third call you monitor, average handling time, let's say, is 58 minutes. Fourth call you monitor, let's say it is 2 minutes. Fifth call, let's say 60 minutes. Sixth call, let's say 90 minutes. Seventh call, let's say 1 minute. We know there is some problem here. It is all over the places.
Right.
Right. There's a lot of variation. I mean, you can never staff the right number of people to take call. You don't know, what's going to happen. Next call, would it be a higher duration call, or would it be, only 2 minutes call? Right. So in this kind of scenario, do you think standard deviation would be very high or very low?
Very high.
Very high, because there's a lot of variation here. Right. So in a standard deviation is telling us how dispersed our data is. Is it very close to each other? Like the one that we have here, it is still very close to each other comparatively.
Right.
Or the one that we have here, it is, very dispersed. Okay. So standard deviation is a measure of dispersion. The way to calculate standard deviation is so ST-dev S. S is for a sample. We want to calculate standard deviation for this. It is 129.09. So just by looking at standard deviation, we would not know whether it is high or low, right? So because here the difference is hundreds in hundreds. There in the average handling time, the difference was in tens, right? So we cannot compare. So we always have to combine it with the mean and see. Okay, so we are beginning to approach the concept of Six Sigma. Is the concept of standard deviation clear to you? It is one of the most important concept in the entire Six Sigma studies, because everything is based on this standard deviation calculation. So I don't want you to remember the formula, but the concept should be clear, that what is standard deviation and how it is helping us to interpret the data.
I'm good if I can figure it on Excel.
All right. All right. Perfect. Yes. Excel is there for our help, Sometimes I wonder, what we would have done if the Excel would have not been there. Anyways, I'll move ahead.